Hello, everybody. Just getting up the whole test here. I was going to go over one of the examples similar to what you'll see on the test. Can you hear me?
Yes.
Yes. Thank you. Thank you. All right, let's get to sharing.
I can hear you.
Thank you. All right, still waiting for this thing to come up. Word has not been my friend on this computer for some reason. There we go.
Is our test next week?
Is it next week? You know what? I don't know.
Wasn't it like November 6th or something like that?
Oh God, I don't know if it's quite that far away. Let's have a look.
I lose track of time.
It's in the syllabus. I don't know. Let's have a look. Where are we? All right. Here we go. No, not November 6th. It looks like it's November 4th.
Okay.
Yeah, November 6th is close. I mean, yeah. So you know, it's a little ways away. You'll have plenty of time to study, that's for sure, because we'll get done with the material, at least the reactions fairly early, which gives you time to go through them and get the mechanisms down, for those who choose to do it. But I know at least 2/3 of you won't. 2/3 of you are sitting there saying, look, the old man's wrong. He's wrong. There's no way I'm going to learn all these mechanisms. No absolute way. I'm just going to memorize the answers and then just look at the patterns for the products and I'll be done with it. No, the old man's wrong. Well, you know, you can say that, but, you know, I'm the one who's been teaching this for 20-something years. I think I know, you know, and 2/3 of you are just going to sit there and just say, nope, I'm not listening to him. It's a sad story, but it's one we're going to have to deal with. All right, here we go. So here's question 2. We talked about these the other day. This is the situation we were discussing. This is a primary tertiary ether. And I'm going to talk about the mechanisms behind what's going on here. So this is your mission. You already have the products here. So you have to figure out how these products get formed. All right, so that's what we're going to talk about, how these products get formed. Now you'll notice that we have a bunch of products up here that have OHs and BRs. Those are the ones that are a direct result of ether cleavage, which we talked about last time. Now you'll also notice there's these alkenes here. Now these alkenes are a direct result of the reaction of these alcohols to become alkenes. So these alkenes come from the alcohols. And you should immediately be able to tell which alkenes come from which alcohol. So these 2 alkenes here obviously come from this alcohol. You can see my cursor, right?
Yeah.
Okay. And this alkene must come from this alcohol. Is everybody okay with that? Don't worry about how, just be able to look at it and know. You're okay with that? Okay. Well, let's talk about how we get the first 4 products, the top row. And as I said, that is a direct result of ether cleavage. So let's take a look at it. You don't have to draw it exactly as I've drawn it there, and I've drawn it just a little bit differently. Let's see, 1, 2, 3, 4, yep. 1, 2, 3, 4, yep. So the first step is going to be attack of the O on the H+, and this gives us a situation where now the H is joined on and we have an O+. Keep it a little consistent. There we go. So that's the first step. What that does is it makes the alcohol a better leaving group by attaching on to the O. And that is a necessary first step. Where's that H+ come from? Well, it comes from the HBr. So the HBr in and of itself, you don't have to include this, is changing to H+ and Br-. And the reason it would do that is because it's a strong acid and can form H+ pretty easily in solution. Does anybody have any questions so far? Okay. So this is going to form the basis of the attacks that we're going to do. I'm going to do the easiest one first. That's the Sn2 attack, which will appear on the primary side. So if you look at the two sides here, we've got a tertiary side. And on this side, we've got the primary side. Is anybody uncertain about what I mean by tertiary and primary in this context? Okay, so since this is primary, this is going to be an Sn2 process, which means it's going to...
I do have a question about that.
Yeah.
Sorry for interrupting. The tertiary would be like, you know, how many branches, or it relates to how many branches are coming off that carbon, right?
Well, more specifically, Hunter, and how many Cs are coming off the C connected to the O? I'll say it again. How many Cs are coming off the C connected to the O? This is the C connected to the O.
Okay, tertiary, yeah.
Right. And in this case, this is the C connected to the O. And that one only has one C coming off it. That's what I mean by primary and tertiary. So primary is Sn2. Let's try that again. And what we're showing here is a story where a bond is being formed between the Br and the C attached to the O. Then that bond will in turn break. And this all happens simultaneously. And I know it's simultaneous because it's all happening in the same picture. And what that will do is that will give us these two products. Now you'll notice when drawing a mechanism, you don't put a plus in between them. Sometimes those pluses get confused as charges. So I don't do that. I just show the products at each step here. Does anybody have any questions? That's the primary attack. So what I'm going to do now is I'm going to use the same thing as what I had up here. And I'm going to show what the tertiary or Sn1 attack would look like. And the Sn1 attack is a two-step process that first involves the breaking of the CO bond to give this carbocation. And this alcohol. And the Br- then comes in a second step and we get our bromide. So that's not a simultaneous process. That's a process that happens in two steps. You'll notice I don't have to draw the alcohol down with the bromide here. I can just leave it. I'm just draw an arrow to it. That can stay there, that alcohol.
That's a covalent bond between the bromine and the carbon, correct?
Yes, it is. All of these are covalent bonds, every last one of them. All right, any questions about those two methods and why? I mean, look at the first one. This is the Sn2. Just take a look. Look what's happening here. You've got the Br joining and the OH breaking off at the same time. In the Sn1, we contrast it with that. The OH breaks off first and then the Br minus comes in. It's the same steps, just done differently because of the different nature of the carbons attached to the oxygen. Now, I don't want to go into why it's 2 steps for the Sn1 and why it's 1 step for the Sn2. I feel like we've already beaten that horse to death. I beat that horse to death in test 2. I feel like I really did hit that horse hard. So what I want you to do is, if you have doubts about why primary goes Sn2, tertiary goes Sn1, I want you to go back to the Sn1, Sn2 videos in test 2 and take a serious look at that, because that is the reasoning behind why these do what they do. So that explains the formation of these 4 products up here. So you can see them all listed. You've got the first 2 over here. They're these ones here, which I'm putting check marks on. And these 2 here, I'm putting check marks on those 2. So we've got all 4 of those explained. Does anybody have any questions? All right, now let's look at the alkenes. Now the alkenes are a result of elimination from these 2 alcohols that we have here. They're at each end of the list. So I'll focus on the first alcohol here and show how that produces those 2 products. Now, what I had said the other day when we were going through this is that there's 2 mechanisms that we can employ when we're dealing with the elimination of a tertiary alcohol. And this indeed is a tertiary alcohol, this first one that I'm drawing over here. We can do E1 or E2, but for the primary alcohol, that's this guy over here, the one at the end on the right side, he can only react via E2, and that's it. So if you've got a choice for the tertiary between E1 and E2, and you can only do E2 on the secondary, I think it makes sense just to do E2 for everything so you don't get confused. But you could do E1 for the tertiary if you wanted to. Some people do. That's up to them. I don't mind. But you can't do it on the primary. And I gave you reasons for that last time as well. All right, so go on.
We don't need to show the E1 as an option then?
No, Julie, but you're welcome to if you want to.
That's okay.
Makes me wonder why E1 even exists.
Well, you know, that's the thing is that it depends on the conditions in the reaction. It's constant reaction concentrations and all of that as to whether or not it would do more E1 or E2. And I really can't tell based on what I've seen here. So that's why I give you the option of going either way. All right, so in the first step, the O from the alcohol joins onto the H+. Again, the point here is to make this OH a better leaving group by protonating it. Which is what I've done. If I'm doing an E2 mechanism, I'm going to do it in 1 step, just like an Sn2 is 1 step, and E2 is 1 step as well. And you can see that the E2 will be the breaking of the adjacent CH bond, forming the alkene, which is a CC double bond. And then we can also on that same structure, which I'm not going to draw on the same structure, but with the same structure, we can show the formation of the other alkene. Let me try to make it a little bit clearer. Which again involves the loss of the adjacent CH to where the leaving group is. And you can see that when I'm doing a mechanism, I have to account for everything. When I'm just stating products for reactions, I don't really have to show all these inorganic side products that I'm getting, but in a mechanism, I have to show everything that gets formed or lost along the way. All right, so that shows you I'll just write down E2 on each of these. These are E2. Does anybody have any questions about how those alkenes get formed? Now, let me finish this off first before I talk any more about this. I'll move this down here, sorry. Okay, so let's get this last product down here. So we've got the other alkene that we have to explain as well. So the first step is again the addition of the H plus to the OH to make it a better leaving group. So it comes off as water, which is a good leaving group. And that is an E2 mechanism as well, and that explains how we're getting this alkene. And that's the entire answer right there. I want to point something out here. Let's close that down. Look how many points this is worth. It's worth 25 points. It's worth a quarter of the test. If that doesn't show you that I think mechanisms are important, nothing will. I mean, it's not like you can look at question 2 and say, well, look, I can just forget that question. Yeah, I'm just going to blow that one off. I'm happy with a C on this test. But I can promise you this, if you do blow this question off, you'll probably end up failing the test. You'll likely get somewhere in the 40s or 50s. I can almost guarantee it. That's what history tells me. People who blow off question 2 usually get 40 or 50 on the test. I don't know. I don't understand it. I don't understand it. Does anybody have any questions about number 2?
Yeah, I have 2 questions.
Okay.
I think I follow with all the mechanisms you're doing. I think I'll be okay with practice. But
it goes for anybody. Johnson.
Yeah.
Yes.
So I noticed that the H plus isn't written as a product in the original prompt, and is that just because it's kind of inferred from the HBr dissociation?
It's catalytic. It's there at the beginning. It's also there in the end.
Okay.
So
Gotcha.
it's not really doesn't really need to be stated as a product per se.
Okay, makes sense. And the second one is, I think I'm just forgetting it right now, but I can't remember what the difference between E1 and E2 is.
Well, E1, I'll draw an E2. I'll draw an E1 up here, okay? because the tertiaries could be done by E1 if you wanted to. All right. So well, let me see. Make it. I'll start with the product where the H is already joined on to the O. First step is the loss of the OH as water. See, this should look somewhat familiar to you because it's very similar to what we just did. And then we lose the H plus in a second step to form the alkene.
All right, so if I'm following correctly, it's the same steps, just one's done in one step, but the other's done in two.
Yeah, does that look somewhat familiar, Jonathan? As that situation, have we seen that situation somewhere before where there's like one that involves two steps done at the same time and then one that involves those two steps sort of separated out? Have we seen anything like that before?
With the stereochemistry.
No, with the Sn1, Sn2, just up here. See, the Br minus comes in and the OH leaves in one step for the Sn2. And then in the Sn1, the OH leaves first and then the Br minus comes in the second step. Again, it's the same arrows, just done in different order. And that's exactly the way it is down here with the E1, which I'll circle here. And let me put the H plus over here as well. So that's E1. So you can see the difference between E1 and E2. E2 happens in one step, whereas E1 happens in two steps. It's an option. You could do the E1 for the tertiary. You cannot do the E1 on the primary because you'd end up getting a primary C plus at this step, which is impossible because it's so unstable.
Thank you.
Yeah, you're welcome. You're welcome. Does anybody have any other questions about question 2? In the blue book, I have practice for these, and the other day I got an email from somebody. They were claiming that the mechanisms didn't have answers, or the reactions didn't have mechanisms. And what I want to point out again, and I'm going to say this again and state it again. The mechanisms for everything in the blue book is in this file here, mechanisms for test 3 problems, in the same order as they appear starting on page 11 of the blue book file or problems test 3 file. So I'm going to go back and open that again. So this is what I want people to do, but only a third of you will do it, at least that's what history tells me. It's a bit sad, but we're starting on page 11. So the idea is that you show all of these as mechanisms, and then you compare your answers to the ones I have in the file that's just below it, this mechanism for test 3 problems. You don't have to print it out. Some people do, but there they are. Those are the mechanisms, for example, for, whoops. Gosh, I hate this Zoom sometimes. Thinks it's smarter than I am. There we go. So those are the problems, and these are the mechanisms for those problems.
Question while you're in there.
Yeah.
This is a question that goes, I think, back to question 1, so I don't know if you're willing to answer it right now. It has to do with number 29 while you're in there.
I don't want to talk about it right now, Julie. Can we wait till the end?
Of course.
Yeah. Yeah. Presently, I just want to see if we'll get through all this. Then we'll discuss specifics. Okay.
Okay.
But I want to make sure that everybody is doing these problems that are in the blue book doing the mechanisms and then comparing those mechanisms to the ones that are in the mechanisms file. You know, I get a bit despondent at times because I know that people won't do it. I get a bit sad. I kind of take it personally. I know I shouldn't, but I kind of do. And then I have tears. And I lay awake at night and I wonder, are they going to do it? Are they going to do it? I don't know. All right, sorry, Julie, you have a question? Julie.
Would this be the best way to study, you would think, for this?
Absolutely, Sierra.
Okay, because I tend to focus on the practice tests, and to be completely frank, I haven't been doing too hot, so.
Well, that's why, you know, that's the thing. I think that studying the practice tests is not a good idea from the outset. You can look at the practice tests. I would do this stuff first, and I would do it again and again until I understood it, until I heard those angels singing. You know, that's the thing.
Okay.
You do this often enough, you begin to hear these angels.
He's right, because I've actually been studying this with my study partner for hours, and the more you do it, the easier it gets, but it is very time consuming. The practice test isn't going to help until you get these down.
Have you heard any angels, Keisha?
They're whispering.
They're whispering?
Me, but it's getting there. It is getting there.
They get louder and louder the more you do it. Yeah. It's not really an epiphany, so to speak. It's more something that happens gradually.
Yeah, there definitely has been some tears, but it's getting there.
Yes.
Some tears is an understatement. I had rivers. Rivers. Oceans.
Yes. The slings and arrows of outrageous fortune, hey?
Yeah, but the earlier you start, the easier it gets.
Yeah. All right. Does anybody have any questions?
Well, thank you for providing us with good study materials, because I know a lot of professors don't even give like an outline or study guides or anything like that. So I know a lot of us appreciate the things that you do post.
Oh, no, I only do it for one reason. It's just to cover my rear end, Sierra. Nobody can come back at me and talk to Vadim and say, oh, look, he doesn't give enough materials. No, nobody can say that.
Got that right.
They can try, but it's not going to work. So no, I do it because, well, I've been doing it for years, and this is what people have worked on, and people have been successful with it if they've used them, and that's the key, if they've used them. So we'll see. All right, does anybody have any other questions at this point? Oh yeah, let me go back to here, problems test 3. I've got examples. Here we go. Summary of ether mechanisms, and I've got some problems here on page 25, and I've got mechanisms for these. These are in the mechanisms file as well. So 3 examples there that you can look at. Then of course you've got all the old problems. I think actually for question 2, I'm going to say the best method would be to keep on doing those problems on those old tests for number 2 after you've done these here in the problems test 3 file. After you've done these 3 problems, start doing the ones on the old test and just do them again and again and again and again. It'll help you with mechanisms overall as well. Just make sure that you are indeed drawing things with exactitude, with the arrows coming from the bonds when they're breaking, the arrows going towards the spaces between the bonds or towards the atoms when you're forming bonds, that kind of thing. It does matter, and you can't just make up your own. You know, there are correct answers, and it's very difficult for me to give partial credit for garbage. So make sure that you are doing something that makes sense. I mean, I'll know if you're looking at, I'll know if you know what you're doing or you don't know what you're doing. And the last thing you want is for me to think you don't know what you're doing.
So the answers for this practice test problems is just going to be at the bottom, at the end of the file, right?
The practice test problems? The old tests?
No, for this that you have up right now, the answers for these are just at the bottom of the page.
No, they'll be here on the mechanisms file.
Oh, the mechanisms solutions for that. Okay, I just want to
Yeah,
make
so
sure.
that starts on page 25.
Okay, gotcha.
I do actually have the
appreciate it.
problems here as well, but yeah, they're in the mechanisms file.
Okay, yeah, sometimes I
Everything-
just have a hard time knowing what I'm looking at. I'm like, is that the answer? Is that part of the problem? And I'm like, I don't know.
Right, and they're in the same order. See, mechanisms, page 24, number 1. See.
Thank you.
All right. Yeah, so I'm thinking, I'm not going to do another example of those now. I want you to practice those a bit. And on the review day, we'll go over another one of those. I think you'll appreciate the time in between if you can practice them. I don't think doing another one now is going to be very helpful.
What day is going to be review day? Because I know we don't have any class on the 26th.
The review day. Hey, sorry, Sierra, did you say something? Or?
No, that's me, Keisha.
Keisha.
Do you know what day the review day is going to be? Because I know we don't have class on.
Well, the review. No. Well, we don't have class on the 26th. That's next week, but our test isn't until November 4th. So I'm thinking it'll be November 2nd. Keisha.
Okay. Thank you.
The day before election day. Oh, by the way, I voted today. I hope you guys vote too. And I'm just going to say that. Vote. Right?
Is the whole school off for the 26th, or that's just your class?
Oh, it's just me.
Oh, darn it.
It's just me. It's just me traveling. I'm coming back from Ohio that day, so I can't have class.
I think the
Okay.
whole school's off for the 27th, though.
That is true. That's that's
Oh.
that's Discovery Day. So 27th, you do get the day off, but we don't have a Tuesday class. We don't have class on Tuesday in this class. So I don't worry about talking about that.
Well, thank you everyone for informing me, because I'm always the last one to know about these things.
Well, it's not quite as bad this semester, but often what will happen is people think that they don't know there's a day off, and they'll turn up to school anyway, and they'll wonder why the parking lot's empty. I know people in this class who've done that. I'm not going to say who, but I know there's people in the class who've done that. All right, let's see. What are we doing? Let's go back to test 3, and we'll look at the file. Now, there's another mechanism problem on the test as well. That's worth 15 points. So there's 2 mechanism problems worth 40 points in total on the test. And it's virtually impossible to memorize them. Virtually impossible. I mean, some people say they can do it, but history tells me that it's a very, very difficult thing to do. You really have to understand what you're doing. You have to understand the flow of the arrows. You have to have heard the angels. Only the angels can help. Only the angels can help. Okay. Oh, epoxide. So we're going to look at the synthesis of epoxides here. And we talked about this already when we discussed the names of the epoxides. And what we said was the names of the epoxides were actually based upon the names of the alkenes from which they were actually made. You can see the mechanism for the epoxide process. It's a concerted mechanism, very complicated. It's not one you have to know. This is one of those optional mechanisms as well. But the main point that I'm trying to make here is that a trans alkene will give a trans epoxide, and a cis alkene will give a cis epoxide. So just to give you a couple of examples here. So I've got the pictures of trans and cis alkenes here on the slide, and you can see the trans looks like a zigzag and the cis looks more like a cup. So if you had something like this, and we treated it with MCPBA, which is metachloroperbenzoic acid, good oxidizing agent, then what you would end up with, you look at the bond here, and we know that the stereochemistry will be shown for the bonds I'm pointing the arrows to. Those are the ones that are directly attached to the CC double bond. So draw the epoxide in the plane of the page. And you can see all I've done there is just taken that double bond and turned it into a triangle with an O, essentially. And then I made sure that the bonds directly attached, one is a wedge and one is a dash. Now, ensure also, and I'll put this in a square, that you've got the same grouping attached on each side as well. So there's your, there's your 2 carbons there, and there's your 4 carbons there on the sec-butyl and the ethyl on this side. Does anybody have any questions? I'll give an example of a cis. Just do that, that's fine. So again, this is not a mechanism you'd have to know. Some people try and get the bonus point for this one, but it is a tough one to get the bonus point for because it is tough, a tough mechanism. All right, so I draw my epoxide here, and again, the bonds I'm pointing the arrows to are the ones that I want to show the stereochemistry for. And you can either do both wedges or both dashes. Okay. And there's our groupings there. Does anybody have any questions about these kinds of reactions with the epoxides, forming the epoxide? So the MCPBA itself is this compound here. There's the metachloroperbenzoic acid. This is a per acid because it's got an OO single bond in it, like peroxide, per acid. And then the byproduct here is metachlorobenzoic acid. That's the benzoic acid there. All right, any questions?
Yeah, so will that molecule, the MCPBA, be given if we're attempting to get the extra credit?
No.
We'd have to memorize that molecule too.
If you wanted to memorize the mechanism, yeah.
Okay.
Yeah. Well, that's part of the bonus, you know?
So then that will definitely be the oxidizing agent used?
Yes.
Okay.
You'll get one in question 1 too, Jonathan, I guarantee it.
Okay, fair enough.
I'm not going to worry about that. Let's look at epoxide reactions for Grignard reagents. So this is, I'm going to juxtapose this with something we've already seen. So this was, and I'll just draw a little C here and a little C here. We looked at this when we did the Grignard reactions with ketones. Now the mechanism for this one looked a lot like this. And this is why I think it's so important to know these mechanisms, because it just makes life so much easier when you have to figure out what the products are of a certain reaction. So I've done this for a specific reason, because I want you to compare what we're doing with this other reaction here with the epoxides. It's actually very similar. Again, I like these because they really make good use of what the arrows are doing. So I'm just going to follow along with what we have here. So I've got the comment more room made for the C that's on the left side of the epoxide in this case. And what that means is that's where the Grignard reagent is going to attack. Now I'm going to show you the mechanism for this, but what I want you to do is pay special note to the ketone mechanism. You'll see it's very similar. So we're attacking the C that has more room around it, and then the electrons go up on the O. Look at what happened with the epoxide. Sorry, the ketone. Excuse me. Look what happened for ketone. Did exactly the same thing. Well, I mean, as far as the arrows go, you attack the C, double bond O, and then the arrows go up on the O. The same thing happened here, but look at the story it's telling. We're getting a new bond, and the new bond is this one that I'm pointing to here. I'll put a star on it. And the O minus is on the adjacent carbon, like that. And then we get the H plus adding to the O minus. I guess I just want you to see the similarity and the difference, I suppose, between these two processes, the ones I'm circling. You'll notice that the new bond in the ketone appears on the C directly connected to the O, whereas the new bond for the epoxide is on the C adjacent to where the O minus ends up. So that's just an observation. But the thing is that if you know the mechanism and understand the mechanism, then I think you're not memorizing anymore. You're saying, oh, I know exactly what's going to happen because I know the mechanism. And that makes life a bit easier. Does anybody have any questions? All right, the next part forms the basis of the second mechanism problem on test question 4, which is very similar to what we've already done. Oh, sorry, which will be very similar to what we're doing here. You'll see this in a second. We've got two additions that we're going to be talking about. We're talking about an acidic and basic conditions. Let's take a look at the test question Just a little bit of context here. So I'm showing you these two reactions. They give two different products, and you can see that the difference between them is that one is an alcohol and H+, and one is CH3O- and CH3OH. So this one with the H+, I'm calling an acidic mechanism because it's got the acid in it. And the one below it, I'm calling a basic mechanism because it's got a negatively charged species. If you look at the difference in the products, I'm hoping you can see the difference. They're kind of switched. In the H+ one, you've got the OH coming off the end carbon and the OCH3 coming off the middle. And on the one below it, you've got the OCH3 coming off the end and the OH coming off the middle. So because we've got these two different things happening here, they're going by two different mechanisms. But the thing is, you have the products here, so that helps you as well. So let's go through and see the, I'll just do this example here. They're all very similar, the ones on the old test. So they look a lot like this. The only difference will be the groupings on each side. One side will always be always have more room than the other. One side will always have more room than the other, and that's going to kind of be the point here. All right, let's look at the first one and look at the mechanism behind that. In the first step, now remembering that we've got two things here on the arrow, there's no 1, 2. It's not first step, second step. We know the H+ will react because it's more reactive, because it's charged. And it will react by attaching to the O. This is something we've seen a lot of before. H+ always seems to like to attach to oxygens and form this kind of thing with the H attached to the O with the plus on it. And then what will happen is that the bond will break specifically on the left side.
And that's on the left side because the left side has more carbon.
Yeah, and I'll explain in a second. Is that you, Keisha,
Yes.
who's saying that?
Yes.
Okay. It sounds like you're miles away. You probably are, but you know, you've...
No, I'm not.
Okay. I mean, miles away from me. That's what I
Well,
mean.
yeah.
Yeah. And I'll explain in a second why it breaks to the left, not to the right. We'll see. But the CH3OH then can attack the plus. So this is kind of like an Sn1 kind of situation. Two-step jobby. Let me move this stuff down here. Oops. There we go.
Can I ask a question?
Yeah.
You call these alcohol additions,
I do.
but the first thing isn't really an alcohol, is it?
No, the first thing is an epoxide, but it's an alcohol addition to an epoxide, Julie.
Oh, okay.
The CH3OH, that's methanol, that's an alcohol. The other thing's an epoxide. Now you can get a lot of clues as to what's going on by looking at the products, because you can see in the product here, we've got the OCH3 connected to the carbon that's second from the end, and the OH connected to the end carbon, which is what we end up with. And then we break off the H plus, and that gives us our product. All right, so Keisha, you were asking about, we're going to focus on this step. I'm going to put a big star on it. That's what we're going to look at. Let's focus on that step. Now let's look at the consequence of what would happen if we broke the other bond from the epoxide. Now remember, the epoxide is a very unstable creature. It's at 60 degrees bond angles, like an equilateral triangle. So these bonds are very prone to break. And if we did this, broke off the other bond, what we'd end up with is a primary C+, which is very unstable. So I'd want you to see that primary C+ is very unstable. So that's why it doesn't break that way. It'll break towards the other carbon, or it'll break from the other carbon, which is going to leave a secondary C+ in this case, which is going to be more stable than the primary. Now we know from the question where the alcohol's attacked. It attacks where I've got the cursor here, because that's where it's ended up attaching. So we know that's where it attacks. So that helps us with the mechanism as well. Look where the OCH3 is attached in the other example. It's attached off the end. That gives us a clue as to what's going on as well. So for the second one, it looks like this. And then the O- can take an H off one of the alcohol groupings here in the solvent, CH3OH.
I don't understand how come it's okay for it to break on the non-busy side here.
Well, in this case, this is more like an Sn2 process,
Okay.
Julie. Now, the reason we're doing the mechanisms we are, because we know what the products are, Julie. We know what the products are. So if the products are what they are, this is the only way that they can form. We can't form them another way. Otherwise, we're breaking all sorts of rules that would make it not make sense. So that's the final outcome on the second one. So the second one's a lot shorter, as you can see, because this is a one-step process, this Sn2 process, whereas the Sn1 process is more like a two-step process, where this has to break first with the CO bond breaking first, and then the alcohol coming in. Now, my point here is that you can look at the products to tell where things have attacked and how they're going to attack. So in the case of the second one, you can see the OCH3 is on the end. So that's a primary C. And the fact it's primary immediately makes you think of Sn2. And this one here is secondary, which is why I think of Sn1 rather than Sn2. And again, we've got the proof. We know what the products are. So we know where the OCH3 is attached. And that's our initial focus. Where is the OCH3? That's the first question I ask myself when I see this. Where's the OCH3 attached? And as I said, the questions on the tests are all very similar. The only thing that varies is the groupings that are attached on each side here. Usually you'll have a primary side and either a secondary or a tertiary side on the other side. So one side will be primary, one side will be tertiary. All right, does anybody have any questions? I mean, again, I can show you example after example of these, but it's not very useful. The only thing that is useful is you actually putting pen to paper and practicing the mechanisms. That's the only thing that helps. It's the only thing. Watching my videos doesn't help a great deal. It's useful for getting the background behind the mechanisms, but not so useful for actually learning them. The only way to learn these mechanisms is to put pen to paper. I mean, I've had people fill up whole exercise books of these mechanisms in order to get them down. And you know, the way it is for this test 3 is it's very much a bimodal distribution. People get either above 90, maybe half the class gets above 90, and then about a quarter of the class actually gets below 50. So what's the quarter of the class doing? Well, nothing. They might have done 2 hours of study before the test and thought they could BS their way through it. But you can't. You can't. It's not like government or psychology or something. You can't BS your way through it. The only way is to learn the mechanisms. And I don't want people to find out the hard way, but some people will. All right, any questions about number 4? All right, so that's everything. I mean, that's all the reactions that we want to go through. What I want to go through now is tell you exactly what kinds of questions you're going to see as part of question 1. I'll use this as an example. I'll use this test as an example. Usually helps to remind me what's on there. Okay.
I have a question while you're
Yes.
going through this.
Yeah, yes, Keisha
I don't
or
know
Julie.
but I'm not sure if you went through and told us which ones we need to know the mechanisms for on the test and which ones are going to be extra credit.
Right. What I did was I showed you that on the problems test 3 file. Let me see. Hang on. I'll show you exactly where that is.
Question 1, they're all not required, right?
Right. Right, Keisha, starting on page 6, I've got this reaction summary. You'll notice there's ones with stars next to them. Those are the ones I think you should know, those mechanisms. Anything with OPT next to it is optional.
Okay.
Okay, let's see. So this is question 1 that we're talking about. And I'm just going to tell you the kinds of problems you can expect to see for question 1. You will see an esterification. Now you can look through the PowerPoint notes to see what these exactly are. So you'll definitely get an esterification. There's no question about that. You'll get a Williamson ether synthesis. Now, I used to do this because I wanted to make sure that there was names for all of these, but then I changed the way that I do the naming quiz. So Williamson ether synthesis, you'll definitely get one of those. You'll get a hydration. And it will be a hydration, it will be a symmetric alkene. Definitely symmetric, I can tell you that. You'll get a reduction. You'll get an epoxide Grignard. You'll get a ketone or aldehyde Grignard. You'll get an epoxide synthesis. You'll get a dehydration. You'll get a halogenation.
Is a halogenation basically a substitution?
In its own way, yeah, it is. It does actually have a special name. It's called an Sn1.
Okay.
Yes, it is a substitution, yeah. But it could be PBr3 or SOCl2. So you'll get either one of those on the halogenation. And let's see, how many is that? And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And the other ones, let's see, it could be oxidation. Oxidation of alcohol. Let me see. Let me look through the list here. I'll just see what else that could be. There's one other it could be, but I'll show you in a sec. If I can get this damn thing over here. Let's have a look. Just making sure I've got it all covered. Alkoxide, could be alkoxide formation. Yeah. Yeah. So it could be oxidation of alcohol or alkoxide formation. All right, so that's what you're going to see. It's very predictable. It's almost all the reactions. And for each one, you can do an optional mechanism. For each one, you can do an optional mechanism and get a bonus point, as long as that mechanism is completely correct. Now, the other thing I'll mention is that when showing these products, I'm only interested in the organic products, the products that have carbons in them. So you'll notice, for example, for this Williamson ether synthesis, Br- would also be a product, but you don't have to show that to get credit. You would for the mechanism, but if you're just showing the product, I'm not really interested in the Br minus. I'm only interested in the actual product. Does anybody have any questions about what they're going to see for question 1? You know, I'm hoping that there's no real confusion here about how to study, because what you would do here is you start on page 11 here, and these are all the mechanisms. I suppose the other possibility for that last one, I should put that in, is substitution as well. It is to be completely correct. Or substitution. This one here. So that's what you should do, is you should start on page 11 and do all the mechanisms, check them against the mechanisms file, and make sure you're doing them correctly. And that's the best way to learn the reactions. All right, does anybody have any questions?
What does it mean when you write no mechanism? Does that mean there is no mechanism?
Yeah, meaning you can't earn a bonus point for that because I haven't shown you a mechanism for it. I'm not saying there isn't one. There is definitely a mechanism. It's not just one that I haven't gone through.
Oh, okay. And what about that question 29, since you're on that?
Okay,
thing?
yes, let's go take a squiz. Now, is this on the
Yeah, it's right in here.
Okay, let's
right
have
where
it.
you are.
Yeah, okay.
29. So
Yeah.
my question on this is, and maybe I'm doing the wrong thing here. And it looks like you're doing an oxidation with a harsh.
Yes.
Why is it not a carboxylic acid at the end?
Because it's secondary. The alcohol is secondary. It's not primary. Look where the OH is. It's not on the end, is it?
Yeah.
It's in the middle, right? That means it's going to form a ketone as a product.
Okay.
So this OH will turn into a C double bond O. That'll be the product, and that methyl group will still be there.
Thank you.
So I'll just make sure that I clarify that. But you see that group is still there, Julie.
Yeah, I understand now. I forgot about that part of it.
Okay. All right. Does anybody have any other questions? So what we're going to do Wednesday is we'll do synthesis problems, and we'll also do some stuff with the road. Well, I don't know if we'll get to road maps. We'll definitely do road maps on Wednesday of the following week. Remember, Monday next week we won't have class, but Wednesday, yeah, this will give us plenty of time to go over everything. Now we've gone over all the reactions. Nobody has an excuse. I mean, I know there's people who say, "Oh no, I'm not studying anything until we've finished." A lot of people use that as an excuse. They'll say, "No, I can't study till we've finished everything." Well, listen, we finished everything, so you don't have an excuse now. You have to start studying. And I've already told you what to do. You just need to do it. So now it's crunch time. You know, you've got to decide, do you want to pass the class or fail it? And I'm telling you that people who don't do what I'm telling you to do generally fail. I'm just saying. I know what I'm talking about. I've seen it happen too often. All right. Anybody got anything else? Any other questions? Okay, then we'll leave it here for today. I'll see you all later. See you all on Wednesday. If anybody wants to hang around, they can.
Thank you.
Thank you. Bye.
Bye.
Oh, I do have a question.
Yes.
This has to do, I mean, it's a kind of a general question, but it has to do with a different class of mine. What does it mean to drop with a W?
Well, it means you withdraw from the class and you don't fail it. Because
So you don't fail it, so it doesn't look bad. You still have to like basically take it again. But
Yeah,
it
you still have
doesn't
to
look-
take it again, but it won't. The W doesn't affect your GPA.
Oh, okay, I got you. And you don't get a refund, correct?
You don't get a refund, although it's possible to try and get one if there's a specific reason for why you had to get a W.
Okay, thank you. I appreciate it.
Okay, no worries, Sierra.
Have
I
a great
quick
one.
question about next semester.
What's that, Deanna?
I have a quick question about next semester. Is it like
Yeah.
the same setup as this one?
Similar.
Similar?
Hmm.
Okay. It's like same like with I was talking about like workload, like so we only have like tests and stuff.
Yeah, same deal. But the thing is, if you can get through the mechanisms part in test 3 and 4 here, it's going to make it so much easier when you get to organic chem 2, because you will have already been primed for it, because it's all mechanisms all right throughout.
Okay. Okay, nice to know. Thanks.
All right, no worries, Deanna. See you later.